Okay. Shoot, I shouldn't have clicked that so fast. Kaylin can rejoin when necessary. Okay, right. While we're waiting for one person to rejoin us, we were talking about evolution, the dreaded E word. And I talked about, on Monday, we talked about the history of life and what we can learn about it through the fossil record. And I talked a bit about the life of Charles Darwin. And again, I'm not going to test you on biographical details much. Focus when you're studying for this. There are a few names I would expect you to know, and Darwin is certainly one, but I'm not going to test you so much on biographical details as to what he saw and what he did. And we talked about the round the world trip that he was able to take. We talked about, there's so much we could have, I mean, I do teach a whole course in this stuff, but we talked about his visit to the Galapagos Islands and his observing that different islands in this volcanic group had different species living on them. The species were all similar to each other, but yet each one was adapted for a different lifestyle. And it struck him that this might mean that all of those species came from a common ancestor. In the case of the Galapagos finches, maybe one of those South American birds that we saw called grasquets blew over to the Galapagos Islands. They don't normally fly 600 miles over water, but maybe some of them got blown there in a storm or something. We don't really have to know how. But regardless, they got there, they started breeding, and over time, the descendants of that ancestral population started changing into new varieties, new forms, and ultimately the 14 new species that we find in the Galapagos. So crazy idea, but it seemed to explain an awful lot. We talked about various things that it explains, but what's the cause? What's actually making it change? You know, in our day-to-day existence, you know, we don't really see this. You know, you plant seeds from a tomato and you'll get a tomato and not a rose bush. What's that song from the Fantastics musical? Plant a radish, get a radish, not a sauerkraut. That's why I love vegetables. You know what you're about. So where's that change ultimately coming from? And Darwin came up with inspiration from a guy named Thomas Malthus for the idea of natural selection. And I'll go ahead and start the slides now. And let's take a look at how this natural selection business might actually work. Hang on. Let me make sure I've got the right presentation. Okay, sorry, temporary delay. Trying to make sure I've got the right notes queued up and ready to show. Okay, right, here we go. And wait, that's not what I want to present. This is what I want to present. Sorry about that little opening glitch. Wait, this is not what I want to present. Okay, is everybody seeing that? Oh, how big are those islands on the, you mean the Galapagos? How big are those islands to cause these different varieties? Oh, let me see. The islands are about 600 miles off the coast of Ecuador. As to how big they are, pretty tiny specks of land compared to the South American continent, but I would have to look up the exact sizes. I mean, there's a few that are just little rocks in the ocean. They're big enough that they now support, I want to say something like 25,000 people. There's airstrips and tours and not really a city, but decent sized towns in the Galapagos now. So let me see, the largest one is made up of 5 good sized volcanoes that are all kind of glommed together. So overall size might be something on the order of 50 to 100 miles wide, but I would have to look up the actual figures, I'm afraid. Yeah, that's why the gods gave us Wikipedia. The point, actually, I'll get back to the Galapagos in a bit. When I talk about mechanisms of speciation, we'll look at this in a little more detail. All right. Let me see. Am I presenting? I should be presenting. All right. Are you seeing my slides? Somebody type that out on the chat real quick. Yep, you are seeing the slides. Great. Okay. All right. So with a process called artificial selection. Artificial selection goes like this. Individuals in a population vary. In the case of artificial selection, that's individuals in a population of living things that humans are interested in. And human breeders pick out the individuals that vary in ways that they like, encourage those individuals to breed, and discourage the individuals that don't vary in the ways that they like. So a Mexican teosinte grass with slightly bigger seeds or slightly better tasting seeds or slightly easier to remove seed husks or maybe missing seed husks or something like that, or a stem that doesn't shatter to scatter the seeds around, which is what wild grasses do. Individuals in a population of teosinte grass that have desirable traits that people like, people will save those seeds and encourage them to breed. Plants that don't have those traits end up getting cut down. Repeat this over many generations, and you end up with domestic corn. Or in another example, I showed you a cat with curly ears back in 1981 was allowed to have kittens because the owners thought she was adorable. And they selected those offspring that have curly ears like she did and encouraged them to breed. The ones that don't are treated well, but they're spayed or neutered. Repeat this and you end up developing a new breed of cat, and so on. In natural selection, the difference is that natural selection doesn't have people deciding who breeds and who doesn't. The decider, metaphorically, is the environment itself. Individuals vary. Some individuals vary. Why, we'll look at later, but for the moment, we don't need to know. They'll vary in ways that give them better odds, better chance of reproducing in the environment where they live. So if you're a bunny rabbit in the forest and, well, let's say you have a whole population of bunny rabbits in a forest, hopping around and doing bunny rabbit things, and the big bad wolf comes in, some of those bunnies, for reasons that we won't really get into until I've covered more genetics, some of those bunnies will be just a little bit faster, a little bit better able to outrun the wolf. Or some of those rabbits may be more observant and better able to spot the wolf and escape. Or some of them might be better at hiding or maybe better able to blend in with the background. Those individuals have a greater probability that they're going to leave offspring. Those individuals that don't have those traits, that aren't fast or don't blend in or aren't good observers, those are more likely to get eaten and they won't pass their traits on. Repeat this over many generations and you'll get change in that population of rabbits. We were looking at examples of artificial selection, and here's one more just for fun. This is a bushy plant that's native to northern Mexico and the adjacent US. It's a pretty enough plant. In warm climates, it'll live for several years, although in cold climates, winter kills it. It's got bright red berries, and the bright red berries are known as chiltepin. And the bright red berries cause agonizing pain if mammals, including humans, eat them. And only somebody who was either desperate or masochistic would ever eat chiltepin berries. But evidently, somebody in what would later become Mexico several thousand years ago was desperate enough to start eating chiltepines. And, you know, they caused agonizing pain and suffering. And then somebody said, hey, let's do that again, because people are just crazy. And they started planting chiltepines. They recognized that if you plant seeds, you'll get more plants. And they started planting only seeds from the chiltepines that had the biggest berries, or the tastiest berries, or the prettiest berries, or the berries that didn't hurt quite so badly when they were eaten. Chiltepin plants that did have traits that people liked were the ones that got to, you know, have their seeds saved to plant the next generation. Chiltepines that had undesirable traits ended up getting uprooted and thrown out. And over several thousand years, the chiltepin has become this. You have bell peppers up in the top left, which do not cause pain at all. They're completely sweet. Chiles poblanos over in the upper right. Very hot cayenne peppers down in the lower left. Aurora peppers at the lower right are mostly grown as ornamentals, although you can eat them, but they're mostly grown because the peppers are these beautiful red, orange, yellow, and purple colors. And there's hundreds more varieties, everything from Italian sweet peppers to serranos and jalapenos and cascabeles. Almost all of the hot peppers and sweet peppers that you'd eat are descended from chiltepin berries, Capsicum annuum. The only exception would be habanero peppers, which are actually derived from a different species in the genus Capsicum, and some South American peppers like ají peppers that you may or may not have heard of. But almost all of the pepper varieties, whether they're sweet or they're spicy, have been derived from Capsicum annuum, the wild chiltepin. And it's happened only in the past, several thousand years or so. And the process continues. Breeders still develop new varieties of pepper that may be more resistant to pests or bigger or prettier or tastier. There's actually an entire research center for chili pepper research and breeding, of course, in the University of New Mexico, I believe. So yeah, if this law school thing doesn't work out, you could always go be a chili pepper breeder. There are people who specialize in that, and they use natural selection to do it. So that's artificial selection, where individuals vary, people pick out who gets to breed and who doesn't, wash, rinse, repeat, and you get new varieties of living thing. How would it work in natural selection? That's a head louse. And every state, as of a few years ago, had reported super lice, so-called because they fly around with a little cape. Actually, I'm kidding. They're resistant to the most common over-the-counter insecticide called pyrethroids. You would put this insecticide in shampoo It's not too terribly toxic to people, although I still wouldn't want to, drink it in a cocktail or anything. And it's used to kill off head lice. And we didn't have this up until a few years ago when states began reporting super lice that weren't killed by pyrethroids. Why? It's natural selection. It's not artificial because humans aren't consciously trying to do this. Nobody wants, insecticide resistant head lice because ew. But lice naturally vary in their susceptibility to pyrethroids. Some are going to be killed very quickly. Others are just a little bit better able to withstand getting zapped with pyrethroids. So if you have somebody's head that's got head lice on them and you shampoo with pyrethroid shampoo, and maybe you don't do it quite as long as you should, you might kill off 99% of the lice, but 1% of them might survive. And that 1% is going to, be able to breed, lay eggs, and the eggs will hatch into a new generation of head lice, and they will inherit from their parents whatever it is that makes them just a little bit better able to resist pyrethroids. Repeat this over many generations, and you end up with head lice that are completely resistant to pyrethroid insecticides. And you end up with a bunch of kids with miserably itchy scalps. There's another one. In Britain, you have this problem with contamination by heavy metal, especially Judas Priest and Iron Maiden and Saxon. Actually, I'm kidding. You get this in other countries as well, but in places where there's been a lot of metal mining, right, you dig up a rock and you treat it in various ways and you crush it and maybe hit it with toxic chemicals like cyanide to get the metal out, the gold or the silver or whatever it is you're looking for. That leaves behind piles of rubble. And the rubble is, A, often it's not very good soil. B, it is often badly contaminated with heavy metals. And I don't mean music, I mean things like lead and mercury and cadmium and things like that. And what you're seeing here is some grass growing on heavy metal contaminated mining waste. Now, the rubble that they're growing on, first of all, it didn't exist until about 150 years ago when they opened up the mines. So it hasn't been around for a long time. And when it was first formed, nothing could grow on it. What's happened is that grass seeds have drifted onto that rubble pile, as they do, gotten, picked up by animals or blown by the wind or whatever it was. Most of the seeds that fell on that pile of mining rubble would have been poisoned. But it just so happens that it might have taken several years, but eventually some seeds fell onto that soil that were just a little bit more able to resist heavy metal contamination than others. Those seeds managed to grow, and maybe they didn't grow very well, but they grew well enough to survive, reproduce, make more seeds, and then those seeds would inherit whatever it is about those grasses that makes them tolerant of heavy metal. Repeat that over many generations, and you've got a whole bunch of plants growing on heavy metal contaminated rubble. If you want to see this in Arkansas, if you go up on the Buffalo River, there is a ghost town on the banks of the Buffalo called Rush. And it's kind of a neat place to visit. There's these, old buildings that are preserved by the National Park Service. But Rush was an old zinc mining town. And there is a big heap. It's a little hike to get to it, but there's a big heap of crushed rock that's still left over from those old mining operations. And most of that heap, nothing grows on it. It's bad soil, and as far as I know, it's probably contaminated with things like lead. but you can actually see a few grasses that are starting to grow on that heap. And I think the same process is going on there. And that only started happening about 100 years ago is when those mines started shutting down. Maybe not even that much. Another example. Okay, we used to have this pesticide called DDT, dichloro-diphenyl trichloroethane, DDT. It was heavily used in the aftermath of World War II as a mosquito killer. Kids growing up in the 50s in towns with lots of mosquitoes can actually remember DDT trucks going down the street, just spraying that stuff into the air. This is some data from, I believe this is from India. And in 1959, we started seeing DDT-resistant mosquitoes. At the beginning of that time period, if you sprayed mosquitoes with DDT, it would kill roughly 98% of the mosquitoes. Well, the problem is 2% would survive. And those 2% are going to mate. They're going to make babies. And the babies are likely to inherit whatever it is that makes those mosquitoes resistant to DDT. So the mosquitoes that aren't resistant will die. The mosquitoes that are will survive. And DDT-resistant mosquitoes first appeared in India in 1959. In less than 2 years, almost 80% of mosquitoes were resistant to DDT. And this is actually a problem for not just people trying to control insects, but people trying to control weeds in agriculture. It's that pests, insects, and pest weeds often develop resistance to herbicides and pesticides, and it doesn't always take them very long to happen. One of the results of this is that as we see the evolution of pesticide resistance or herbicide resistant weeds, farmers keep having to use more pesticides or herbicides and stronger herbicides, and that can have some pretty bad health impacts on people who get exposed to that stuff. So yeah, a modern problem, but one that's ultimately due to unintentional natural selection. You know, nobody wants DDT-resistant mosquitoes, but that's what we ended up selecting for. The same thing has been going on with bacteria. When penicillin was introduced to civilians just after World War II, it was a wonder drug because it would cure so many bacterial diseases with very few side effects. A few years after that, we started seeing penicillin-resistant bacteria. And we've been in this arms race ever since then, trying to find new antibiotics faster than bacteria can develop resistance to the old ones. You can actually do this in an undergraduate laboratory. You can grow bacteria on a dish with small amounts of antibiotic added, and it will kill almost all of them, but just a couple of them might make it through. And once you have a few of them that make it through, they'll grow, they'll make more like themselves, and then you can expose those bacteria to a bit more antibiotic, and most of them will die, but a few of them will make it and they'll grow, and so on. There are now some disease-causing strains of bacteria that are resistant to almost everything we can throw at them. Tuberculosis is one. Another one is one you might have heard of because it can be transmitted in, college, locker rooms and gym classes and things like that. It's called MRSA, multi-drug resistant Staphylococcus aureus, MRSA. And most of the antibiotics that would normally clear that up right away, it's become resistant to. And the reason is natural selection. I'll give you one last one because it's really cool. I remember this, y'all may not, but in 1986, there was a nuclear reactor in the Ukraine, in what was still the Soviet Union at the time, um, uh, a reactor called Chernobyl, and that reactor melted down
Hey,
and created this. Sorry?
okay.
Okay. That reactor melted down and created this plume of radioactive steam that actually spread to several countries in Europe. Two entire towns had to be evacuated completely. A number of people died, gave their lives trying to contain the release of radioactive waste.
I mean, I have a
And
job. I'm working at Wicked. I'm just not working much because of school. But
okay, dude, your mic's on. Somebody tell whoever that is that his
yeah,
microphone is on. Okay, right. Anyway, um, so they put this concrete dome over the whole thing and just sealed off the reactor from everybody else, and sealed off a wide area of land around there and just abandoned it. But they go back in every so often just to check on what's going on. And in 1997, they found fungi growing inside the old reactor. And this is some of them. They're very close to modern species. You can see spores and you can see hyphae right there. What's different about them is they produce a black pigment. You can see
Greg
it's kind of a
James,
dark
and what'd
gray
you
in
say
color.
to ask him? 0 or 2.9?
Um, yeah, they produce this dark pigment that actually absorbs the radiation coming from, the radioactive elements in the reactor. It absorbs gamma rays, the stuff that made the Incredible Hulk. And not only does it soak up gamma rays, but it seems to be able somehow to harness gamma rays as an energy source. These fungi will actually grow faster with radiation than without it, and they'll grow towards radiation the way that plants grow towards light. So not only do we have fungi that can resist radiation, we have fungi that can actually use it as an energy source the way plants use light. That's a really neat trick as to how they're able to do that. And we know that these only have appeared in the past, 23, 25 years. And, we're pretty sure that they didn't exist in the beginning, because when the Chernobyl reactor went off, I mean, the core of the reactor completely melted and burned a hole into the basement. And, you had a life expectancy of maybe 30 seconds if you went down there. It was much too dangerous for, human life. But a few spores must have managed to get in, and maybe most of them got killed, but the ones that survived were able to grow just a bit. And in every generation, the ones that could grow a little bit better in the presence of radioactivity were the ones that survived, reproduced, and started developing ways to not only resist this radiation, but power themselves on it. That's really cool. All right, I just saw a ding dong, so if you'll give me just a second, I'll see what that's about. But while we're doing that, so that's how natural selection works. Individuals vary. Some individuals have a better chance than others of surviving and reproducing. Um, okay, so we got that mic taken care of. All right. Um, yeah, I'm not particularly bothered, but I just want to make sure you're not, saying anything that, you know, telling any secrets or anything like that. Right. So in natural selection, individuals vary. The variation is inherited. It gets passed on from one generation to the next. And some of that variation makes a difference in your chances of not just surviving, but reproducing. Now, this is sometimes expressed in the sentence, survival of the fittest. And I hate that. And I start twitching uncontrollably whenever somebody says the word survival of the fittest. And there's several reasons. One is that Darwin didn't actually say that. That was coined by a philosopher named Herbert Spencer, who was one of the dullest people in history. And another thing is that it's not about survival, it's about reproducing. It doesn't matter how good you are at surviving if you do not reproduce. And the third thing is that fittest doesn't necessarily mean strongest or toughest or meanest. It has a technical meaning, but it doesn't mean what most people think of when they think of as fit. So I don't like the phrase survival of the fittest because it's misleading in several ways. Right, there's one third type of selection that Darwin studied called sexual selection. And in this one, individuals vary. Those that have traits that the opposite sex prefers have a better chance of reproducing and passing on those traits. So if you are a bird that sings in a particularly attractive way, the ladybirds are going to want to get with you and have your babies or have your eggs, and you'll leave lots of offspring that also sing the way that you do. So those traits could be sound signals, or one that you can see around here at this time of year. In fact, there's a bunch in my neighborhood, is Tyrannus forficatus, the scissor-tailed flycatcher. These birds tend to sit up on telephone wires a lot. I've seen them on lampposts. I've even seen them I've seen them within the city limits of Conway. You might not have to go far to find them. The males have these very long forked tails. And when the males are trying to find a lady friend, the males will fly up on these telephone wires and periodically launch themselves off and do these swooping and looping acrobatic flights and wiggle those big long tail feathers and try to show them off. And females prefer to mate with the male that does the best job of twerking those big tail feathers. The females like males with big tail feathers that they can shake adorably, which makes me think of that scene in the Blues Brothers. Come on, baby, let me see you shake a tail feather. Bend over, let me see you shake a tail feather. Well, they're doing it right now. You could go out and observe this afternoon if you wanted. Sometimes the signals might be colorful. That's an Australian peacock spider, where the males, they're actually very small. They're less than a centimeter. They're not nearly that as big as they look. But the males will get up on a branch and start lifting their abdomens into the air and shaking them. And the abdomens have these brilliant iridescent colors. And they'll take their those legs that have the white tips on them and start waving them around and doing this crazy twerking dance. And the females evidently prefer to mate with the males that have the brightest abdomens and do the best ritual dancing. So if you're a male with a drab abdomen, you're never going to get the ladies, and you'll end up doing the spider equivalent of, sitting in your mom's basement and playing Minecraft or whatever it is. If you're a spider of this species and you have a really bright abdomen, you're going to make lots of offspring, and they'll inherit your bright abdomen. Repeat that over many generations, and you end up with spiders with crazy bright abdomens. Or birds with extremely long tail feathers, or whatever it might be. What's so great about having a brilliant abdomen or long tail feathers? Well, it actually takes me about a week to talk about this in my upper division course, and there's several things that it can be. But in many cases, certain traits are indicators of quality. If you're a male that has these traits, you'll have offspring that are likely to survive. You'll have high quality offspring. And a great example of this is a fish that I don't think we get in Arkansas. Tends to live up farther north, but you'll find it on both the Atlantic and Pacific coasts of places like New England or Washington State, Oregon, Baja California. This is the three-spine stickleback. Fortunately, it's not nickelback, because I wouldn't be able to talk about it then. This is the stickleback, very different. And what you've got there is a female between two males, and the males have that bright red on the face. And it's hard to see in this picture, but that red can actually extend onto the belly. And when a boy stickleback decides that it's time for him to get a date, he starts wiggling around in the water and doing this behavior called the headstanding dance, showing off his brilliant red belly. And the ladies will look him over, and one might decide to come back to the burrow that he's dug on the bottom of the stream and lay her eggs in it if she likes the look of his bright red belly and the way that he is shaking it. What's so great about a bright red belly? It turns out that males that have bright red, males that have more red, are more resistant to infection by parasites. And more to the point, their offspring are more resistant to parasites. There's a number of parasites in freshwater streams that can infect fish. If you get a lot of them, overall health can be severely compromised. You can end up really sick. So if you're a female and you don't prefer bright red males, but you're happy to mate with a drab male, then your offspring are going to tend to have more parasites and be likelier to get sick and maybe die or not live their full lifespan or something like that. If you're a female that does prefer males that are bright red, then you're likelier to have healthy offspring that are going to be resistant to parasites. For reasons I don't need to get into, red seems to be correlated with better states of health, and in particular, a stronger immune system. At least in sticklebacks and also in some other fish and birds and things like that. So a female that prefers bright red bellies is going to leave more babies than a female that prefers drab bellies. And so a female that prefers bright red bellies will have lots of babies, and they will inherit the preference. And they'll also inherit the trait from their dad, because they'll take after their dad and inherit that bright red belly. So sexual selection can take a lot of forms, but often, although not always, sexual selection is actually a way in which mates advertise and select traits that are markers of overall health and quality. Right? You mate with a bright red stickleback, you know you're going to be having healthy babies. And the stickleback fish don't necessarily know this. It's just that those sticklebacks that have bright red bellies and that prefer bright red bellies leave more babies than those sticklebacks that don't. And that's all there is to it. All right, that's actually a pretty good place to pause. I've got 9:51. So I'm going to stop the slides. And if anybody's got some quick questions, go ahead and type them in. So there we are. All right, I have stopped presenting, and I have got 9:52. So I'll give you guys about 13 minutes to get your coffee or whatever, and we'll come back at oh, what the heck? Yeah, come back at about 10:05. All right. I will pause the recording, and I will see you when we get back.